for this Gian course. Now I request Bhusan Gopaluni sir to felicitate the Sudarshan by offering him the sapling. Okay, now we will start with digital twin. So today sir will be taking about some theory, and tomorrow he wants all the laptops should be connected with one Wi-Fi so that you can do some hands-on. Okay, if possible today also we'll try. If it's not working tomorrow, surely we'll have hands-on session with. But it should be all should be connected in one Wi-Fi. Okay, yeah, that's what sir told me. So bring the laptop if you don't have today, you please bring it tomorrow. Okay? Yeah. Sir, please come.
So good evening to everyone. Myself Sudarshan from BA Microsystems. So I am going to take about digital twin in process industries. So first of all I will just explain about that what is our company has done. After that we will see about what are the types of industries, what are the process industries available in that. After that what is digital twin, like that we will go on, keeps on going. So as for before itself sir told that we have a lab equipment supplier. So we have given solutions for more than 3,000 of products we have given in, especially for E&I, ECE, EEE, instrumentation, controls and mechanicals. All the lab equipments we have supplied. We are having our own R&D departments also. So which will be approved, recognized by the Department of Science and Industrial Research, Government of India. So through that also we are doing some innovations for EVs, all the things, and then we can also supply for guide the small scale industries for production and all the things also we are also doing. So and we are a channel partner of Siemens. So I am going to tell about that all the Siemens software which will be useful for digital twin, like that. So once we are a educational partner for Siemens, so we are selling all the automation oriented things, and then softwares which are having in that PLM life cycles, all the things we can able to sell it to industries. So regarding on that some softwares, how it will be useful for creating a digital twin, like that, all the things we are going to see in the upcoming sessions. So mainly we are going to see on these types only. So majorly industries will have two types. We will have discrete industries and process industries. I am going to focus more on about only process industries, because discrete industries all are more known about the digital twin, digitalization all has been happened in nowadays. But in process industry it will be more complicated, because of the discrete industries will have machines, CNC machines, lathe, like that. It's mainly having that mixed product or a single product. In car manufacturing industries they are having some single parts manufacturing. So like that different types of which will not be a continuous process. It will be depend upon that some other process. Once it will come, it will assemble at one places and then they will distribute it. So these are that one types of industries that are discrete industries. But I am going to mainly speaking about that process industries. Process industries are mainly on continuous flow industries. So mainly if you are speaking about that, if some raw material or any brackages stops, then the whole industry has to be stopped. So like it will be working on 24/7 continuously, depend upon that requirement, what are the industries are running, which are all comes under that process industries. So in that there must be many process has to be done in that industries like that. So under the process industries there are oil and gas, chemical plants are there, power plant is one of the best example for process industries are there, pharmaceutical industries, food and beverages industries, all the things are comes under that process industries. So which will have some many processes which will undergoes in one places, that all comes under that process industries. So in process industries, how we can able to digitalization. So digital twin, how we are going to create all the things. So that's what we are going to see about in all the sessions. What are the things available? Some examples of process industries are metal manufacturing industry, refinery industries, so cement industries. So all the things are water treatment plant also there. So here there are mainly they have some things which will be comes under some processes, and then here they have a boilers, all the things how they can be able to digitalize. So these are such a complicated things. So these things has to be digitalized. Once it will be digitalized, we can able to create a digital twin. We can able to implement any algorithm, AI, machine learning, all the things can be we can able to apply on. Once it can be able to digitalize only, we can able to apply all the things, how it will works, all the things can be we can able to find out on that. So for that only mainly we are going to focus on the process industries in that areas. So after that I am going to speak about the digital twin. So main digital twin is an virtual representation of any physical object. So if you have any one object which will be replicated in your systems in a simulation mode or model, so in a same replica, so that is called as an digital twin. So in our entire life cycle, what are the damages it will happen, so all the things can be updated to your digital plan. So that's what it will be called as a digital twin. And then it will have a real-time data also integrated with any real-time data. So if it works for 24 hours, in that 10 hours it will work, so how much it will defect, all the things real-time data will be coupled with that virtual replica plans also it is possible in this. And then it enables that decision making. So once you create a digital twin, it will be able to create a decision making, and then optimization, how you can predictive compatibilities, all the things can be we can able to achieve using that digital twin. So main characteristics of digital twin is an real-time synchronization, and then lifetime model, life cycle based modeling, and then cloud accessibility also available in the digital twin, and then two-way information flow. The major thing is there should be a two-way information flow is there. In that real-time synchronization, we will continuously update the live data. So if there is any fault in that real plant, it will updated in your digital twin plans also. So all the things how they are controlling, and then enabling accuracy, all the things can be able to find out in this. And then life cycle based modeling, from the before itself I have told that from the design up to the commissioning to operate and decommissioning. So once that all the stages we can able to get the data, entire life cycle of this model can be we can able to integrate in this, and then we can able to send the data to cloud and then receive data from the cloud. Cloud accessibility is also there in that part of digital twin. And then we have a two-way flow information which will be digital twin can give bidirectionality with the real asset. Not only that it will monitoring that values, it will give some feedbacks, so how we can change that real models, and then all the two-way directional flow can be we can able to give to the digital twins. So once you are I am speaking about simulation, all the things, but simulation will have some features, and then digital twin have more features. So digital twin versus simulation. Simulation is only one-time analysis, so which will be a single time. Once you create a product, and then if your simulation has been done. But in digital twin, it will continuous to the entire life cycles. That is a major difference between that simulation and then digital twin. And then data usage also for digital twin, real-time data from the sensors. So what is the level of the tank? So what is that all the sensor data, pressure, temperature available on the tanks, all the things can be real-time data, and then control systems, how it will be controlling, all the things can be, we can able to couple with that real-time data. But in simulation mode, what are the histories available, static data we are having that, so that what only we can able to implement in that. And then interaction, as before I said, it is one-way interaction, model to result, that will be two-way interaction. Asset and modeling, we can able to interact with each other, and then we can in simulation we are going with this only one process, but in digital twin we can have a multiples of process, so we can able to go with a multiple interaction of process. Here we can able to do that maintaining level, pressure, all the things can be combined in one process, and then another one will having that filling station, all the things can be, we can able to create a one platform with a digital twin. But in simulation we can mainly focus on only one process, how it is filling, so what is the algorithm, like that only one process we are going to used in that simulations, all the things. But in digital twin you can able to get all the things in an multiples of process. And then adaptability also, it will be limitations, some limitations will be available for simulation, all the things. But in digital twin we can self-updating, and then we can able to put a AI, ML algorithm, all the things, whatever that you want to implement, all the things we can able to place it on the digital twin. It will be easy for simulation, all the things, only have limitations on the thing. And we have I am speaking more on digitalization. So why we are going to digitalization a factory? So once we want to create a digital twin, the core factor is on digitalization. So if you digitalization a factory, then it will be having all the digital data which will be having in the cloud, all the things we can able to utilize for digitalization for real-time monitorings, and then simulation purpose, and then information of the optimization of the physical asset. So if there is any changes in that physical asset, then it will cause more optimization, all the things can be, we can able to analyze using that using the digital twin, by using the digitalization of your entire data. So main thing you want to digitalize that entire industries. So majorly how we can able to digitalize, so what are the need for digitalization, all the things can be in industries, they are growing up mainly fastest. For that it needs digitalization is an essential for competitive world. And then it drives an automation, enables real-time digital decision makings, and then we can have more digitalization in that. So from digitalization happen in all the places, but in process industry it will be happening very less amounts only. But for that in bookstores are now not available, it will be all available in e-books, like that. Yellow papers, letters are now changes to emails, like that. And then recordings are changes to streamings, like before it was we are having that tapes and CDs, now we are having that online streaming. So like that all the things can be digitalized. And then from before we have called the taxis, now it will booking through the mobile apps. So like that entire things are getting digitalization. So once you get it digitalized, we can able to use the data from there, and then we can able to use that algorithm, any AI, all the things can be, we can able to implement on that platforms. So for that now we are going to see about the digitalization on process industries. And Government of India is also focusing on land digitalization to avoid that illegal activities in that lands. So all the things can be getting digitalized. So but in process industries only very less amount of digitalization is happening on that. So how it can be happened, all the things majorly they have multiples of softwares available in that platforms. So I am going to see how that Siemens softwares will works, all the things here. While you increasing once you digitalize, you can yield a more productivity also, you can able to increase the productivity of that industries, and then you can able to increase the computer power, and then communications and new sensors we can able to implement. Cloud computing is also possible, all the things can be, we can able to get all the data. So once you digitalize, you can able to speak each and every sensors and IOs, all the things can be, we can able to speak endpoint to cloud easily. We can able to speak with that each and every modules, and then predictive maintenance also we can able to find machine learnings and secure conductivity, and then functional safety, edge computing. So like that, all the things can be, we can able to get all the data in one platform from the cloud itself. So in Siemens there are mainly we have three types of platforms. One will be the PLM, and second one is an MES, third one is an TIA. So these are the digital enterprises softwares. So in that, PLM is an product life cycle management, MES is an manufacturing execution system, TIA is an totally integrated automation system. So these three types of softwares will majorly act for a digital enterprises in all the industries. So in PLM there are so many softwares are there. Under the Team Center is there, NX is there, Sim Center is there, and COMAS is there. So and then MES Cinematics IT is there. In the TIA is an total integrated automation, will have a semantics and cinematic, cinematics, all the things are there. So and then these are the following softwares and hardwares used for digitalization. These are some softwares we are going to use for digitalization. Some hardwares also, right sides we have. So COMAS is one of the software we are going to see in this sessions, and then CIMIT. So COMAS is an plant engineering software, CIMIT is an simulation software, and then we have a TIA portal which will be a automation software, and then MATLAB supports SCADA, PCS7, NX CAD/CAM, SimCenter, AmSim, and then MindSphere. All some softwares are available for creating a digitalization and digital twin of an process industry. Some hardwares also listed below. So hardwares we are going to see about that any process loops. So as far as Sir said that there will be a 4-tank systems or any process control loop, process control labs unit can be, we can able to use in that. And then we have a SIMO code, switchgear products, RFIDs, and then we have a hardwares which will be called PLCs, programmable logical controller for automation, and then DCS is also available on that. Distributed IOs, like in the DCS, Siemens have a AS410 smart controller which will be effective, and then we have add-on models in that, ET200SP, PAs, like that different models are available for hardwares also. So how that hardware will mingle with that software for creating a digitalization, all the things can be, we can able to find in that. So for digital enterprises there will be a process industries which are their softwares are works in that, discrete industries which are the softwares are working in that. In that, COMAS will be makes a major role for from the plant process design, engineering, commissioning, operation, services, all the things will be comes under that one platform for process industry, which will be called as an COMAS, through which we can able to get all the datas, and then we can able to going for a simulation, MES, all the things can be will comes under that CIMIT, all the things. So and then automation, how we can done with that TIA, and then we have a PCS7, all the things as there. So yeah, COMAS, CIMIT, and TIA portal. Examples of a system, water management plant, how we are going to create a digitalization. Entire plant, we will go with some simple example. Simple liquid level system also possible, can able to give. Disadvantages of digital twin, it will cost will be high once you create a digital twin, but it will be more effective for upgradation, all the things. It will be effective for creating a digital twin. And then if you want to simulate all the things, it will be very useful, but cost of that digitalization will be very high. Digital twin will be very high. Application. Yeah, it will be running in your desktop only. So it will be running on your softwares. So entire plant will be data will be available in your desktop. It will be running, and then if you want to change any data in your software itself, we can able to change, and then if it works, we can able to implement in that plants. So it will be real time data, all the things. So you don't disturb that real plant. So it will be running in your desktop through simulation, all the things. But it will be a real time replica of your original plant. So it will be same as this shape. So all the things, what are the capacity, all the things which will be having in your here desktop, at what pressure it will break. So how much it will take, and all the things we can able to calculate it here. So for that, so how we can improve that material, all the things we can able to test it in your simulation itself. So digital twin itself, we can able to solve all the issues in your facing in your plant. Not only like that, we can able to know that maintenance, predictive maintenance, what are the maintenance available in that plants. So how we can solve that, all the things, everything we can able to view in your desktop itself. After that, before we can plan all the things which will happen in that plants, all the things we can able to identify in your simulation mode itself. Yeah, we can able to replicate that one also. Just I will show that. And then we can able to create a VR also for entire plants. So this is one plant, so which will be a miniature of a lab setup, which will be having that paint filling, paint manufacturing industries. So there are different types of colors available. So in that plant itself, we can able to walk through. On that time itself, we can able to get all the real time data, whatever that available. Also we can able to monitor how much pressure. So like that, everything we can able to get a data in a virtual mode. Once you want to simulate all the things, what are the maintenance records, data sheets, everything we can able to get it from one simulation platform. Through that we can able to get all the data. We can able to monitor, and then training scenarios, all the things we can able to give it in this platform itself. So we only want to create using any softwares, NX or any CAD models. If we have, we can able to build it here. And then for digital data also we can able to get it mainly using this GOMOS itself. There will be multiples of platforms. So here we can able to create some, for that same plant it will be some PNID diagrams, how it will be having that. So piping and instrumentation diagrams, all the things also we can able to integrate. So same PNID diagrams, how it will be integrated with electrical diagram, same motor is there. So single motor, how it will be works in different places. And then like data sheets, all the things we can able to view in one digitalization platform. So this is some loop diagrams. Yeah, we can take, yeah. It will be working on that simulations. It will be running on that PCS7 or any automation. Okay. Fault maintenance we can able to predict, predictive maintenance, what are the schedule for maintenance, all the things we can able to do. Fault we can, if the sensor fails, once you done with the simulations, we can able to understand sometimes how long it will works, like that. We can able to find out that when it will failure, like that we can able to find. No, failure rate, CAD model. Yeah, okay. Yeah, 2 HP is not same as like that 5 HP, but all the things, data will be available in that. If there is a 2 HP motor, data sheets, all the things will be available. All the entire data will be digitalized. Okay, but it is just like that, but we can able to integrate in one platforms entire diagrams in COMAS itself. We can able to create AR, VR, and then we can able to create all digitalized platform like PFD, process flow diagram, by VNIT. VR, AR, it is not possible, I think so, but basics we can able to do. Failure that. Okay, I will just demonstrate all the things on last day. Friday, I will demonstrate with my laptop how all the digital twin works, all the things. We can able to get all the real-time data. It will running in my office. So like same data, I can took it from there, and then I can show it to you on the Thursday. I can show you how it will be running. So what is the real-time plans running, real-time data is there, how it will be simulating, all the things, real examples I will give it on final classes. Through that you can get more ideas about on the how it will works, all the things. Okay. Good day. What? Proteus. I don't know that software Proteus. What is that's what I am also. Proteus.
I think Proteus is a software where all the microcontrollers will be available.
Okay.
You just take the microcontroller. And the way you have to program the microcontrollers is that it will be programmed in real world.
Okay.
You can simulate a similar environment there. You can see whether outputs are No. Only software. Let's suppose you want to work on admin or something. You have to drag and drop there. You have to write a program accordingly. It will show you the output. Let's suppose you want to click the LED.
Okay.
So LED also to be dragged there, and it will show you the same output. And later on, when you will try it on your real product, it will work fine. So it is to test the program.
Not like that, but similar like that only. But yes, in that SIMIT is an exact like that only. SIMIT is an software used for simulation. There itself we can able to simulate that which will be running in that real plant. No. So all the data we can able to simulate in an SIMIT. SIMIT is an virtual representation of an software. So simulation software. Whatever that you have said, that will be real hardware will be available somewhere else. So we don't touch that real hardware. So same real hardware will be available in a virtually, which will called available in an SIMIT. So we can run that virtual hardware. So once you done testing all that, then we can able to implement in that real hardware. So all the things also possible. So that will be happening in an SIMIT software, which will be also, I am going to just give some small example on that SIMIT also. So SIMIT software will works based upon your Proteus software like that. Similar for SIMIT, but COMAS is entirely different. COMAS software is meant for only for digitalization, all the things. So simulation orientation will be available on that SIMIT software. So SIMIT is totally same as whatever that you have tell like that. So entire digitalization platform. So you tell that one Arduino, Atmega, all the things you have no. So all the things will be available in that SIMIT. We have any process industries. If you have any PNIDs like this, so we can able to import in SIMIT, it will simulate all the things. So but it is not running in a real plant. So same things will be happen in that SIMIT also. So which can able to know when that plant will be going to defect, all the things can be, we can able to find out in that SIMIT simulation software only. So we can going to predict using that SIMIT only. So it will running on any controllers like you are telling us Arduino like that. For industries they are going with DCS, distributed control systems, or PLCs like that they are going to use. So in that how they which will also we can able to create a simulated mode also. So like PLCs or DCS, we have a PLC sim advance, so which will be created in your PC itself. So no need for any PLC controllers like any S7200 PLC you are required, no, which will be not needed for your simulation. So which can you can write any programs also, we can able to dump that programs in your simulation mode in your laptops itself. So through that we can able to run that SIMIT simulations also, any all the things also possible in that. Yeah. Oh, okay. You can able to test it in SIMIT also. Yeah. Yeah, correct. Yeah, we can able to map with that parallelly with that real-time hardware also. Through your controller will have a OPC UA data communications or any communication protocol, Modbus TCP. So through that we can get a real-time data, and then we can able to put it in your virtual world also possible in this. Yeah, software also, yeah. Through that any communication protocols. In that COMAS itself we have a OPC open protocol, OPC UA protocol is there. So through that we can able to read a data from that your controller only. So first of all your controller has to know that sensor has to defect, it does not give any data to the controller. So then the data will not reflect in your real virtual plants also. Yeah. Design a drone. Drone, okay. Drone is not comes under the entire process. Okay. Tell. Yeah, tell motor. But okay, tell me what you want to design in motor. Okay. No. Process oriented only we can able to do it in this software, which will be very easier for you also. But in SIMIT we can able to simulate any CNC machines, all the things. I am going to use only on that process industry. SIMIT is a common platform we can able to use for discrete industries also. So like you are asking drone, how you are running, simulation, all the things can be, we can able to done simulation in SIMIT software also, which will be also very useful for getting that how it will running. So SIMIT is a common platform which will be for both discrete and process industries. So in that I am going to speak only about the process industries, which will be I am more familiar with that there, because there will be all drives, all the things, CNC machines, all the things are available in that SIMIT simulation software. So which can be our own world also there. There will be we can able to get it, and then simulation all the possibles are there in that. Okay. I mean that's like that. I doesn't check all the things. I don't know that disturbance. If sensors give the data, we can able to read, but we can't able to any give disturbance to some such any things in that simulation. It's not possible. I think so. That is possible. Yeah. What? Starter? I can't understand. What you are saying? Tata? English. Hindi. Yeah, analyze the data. Yeah, we can able to analyze all the data. What are the previous data? So histories, all the things we can able to get all the data in one platform. And then we can able to simulate accordingly. We can able to train simulation. All the things also possible. Previous data, historical data, the future, how it will be happening. All the data we can able to get it from that things also possible in that. We can try, sir, tomorrow. But
Possible. You just suggest me if I am wrong, if you want. I am also wrong. So if small liquid level system is there, input is there, output is there.
okay.
Can we convert this to digital twin? What will happen if this is going to be equal percentage or something like that?
Okay. Okay, fine. We can do it.
Is it what I'm asking? I'm just saying that we will take one square tank. Okay. Control valve is there. First we'll do with the digital twin. After that, change the political tank, change the control valve. How the process is changing. The data from the sensor, everything.
Okay, we can change this and then we can able to simulate all the things. Then we can able to implement in real plant also possible. So whatever the things we have, we can able to create a digital twin. But there will be some real hardware if it available. We can get all the data from that real hardware. We can able to create it. If not there, we can assume it that it will be a real hardware which we are going to create. So from that we are going to simulate all the things. Whatever that, and then if you want to change that parameters, what are that issues are available facing you are in that, all the things can be, we can able to get all the issues, we can able to sort it out.
We know the equation as for the square and A is equal to dx by dt is equal to 1 minus A. So that equation A is equal to the differential equation wise it will come like this. Input minus output. Okay. Area is going to be a square tank. So it will be A into B into H. Okay. So it will be very easy. But when it goes to this kind of spherical, conical, the height will be different. But parameter all are same. Is it clear? So that's what I'm asking.
Okay.
We can change this to
Area,
spherical, conical,
area.
whatever way we want, so that, and even we can change the control board also and check it out what is happening. Equal percentage control board is there, relay control board is there. Change the control board, what is happening to the right? It will be the same, it should not be the same. Yes.
So, just what I have said that digital twin in process industries is an mainly digitalization of a plant having a engineering data and then simulation and automation. So, these three are the main process. So, engineering we are going to use for COMAS, for simulation we are going to use a SIMIT, for automation we can have any type of automation engineering work like PLCs or SCADA, whatever that DCS or PCS7, whatever that you have that automation it will be works on that. These three things are mainly for creating a digital twin in and process industries. So first we are going to see about that COMAS software. So COMAS is a core for digitalization software. So that can drives the creation and maintenance of a digital twin in and process industries. So how that process industries we are going to create, maintain, all the things can be comes under that COMAS platform itself. So simulation, all the things we will see in next. First we will see that COMAS, how it will be works, what are the availables in that COMAS. So because tomorrow we are going to see about that COMAS software, how we are going to create a digitalization, AR, VR implementation, all the things will be going for next 3 to 4 classes. Last classes we have a SIMIT and then we have automations, all the things. So here COMAS is an plant engineering software, and we can able to create engineering data, operation data, maintenance data, all the things also possible. We can able to integrate with the CAE systems also. So in major things is we have a common database. So COMAS is one common database. So before that we have common database because we have a different data format, which will be dangerous in process industries. In process industries there are multiples of data, like they have an search data in Excel, they have a data sheets, device specification, tag list, which will be comes under that Excel data, access data, Word data they have, and then some of them will have AutoCAD data, piping and instrumentation diagrams, and then 3D models, 2D diagrams, and then we have a PDF format, manuals, and then all the things will be available in that PDF format, and then we have hardware configurations will have that separate orientations, and then which will not speak with one with each others. So all has to be in a different data format, which will not communicate with one another. So it will be very dangerous for creating a digital data of an entire plants in a different softwares or different platform comes in one places, because in a process industries they have multiples of softwares available. So for that I will going to introduce one software which will be having a unique nature, and then we can able to use it for an entire life cycle of an process industries. All the entire data will be comes under that single platform. Through that we can able to view all the data, and then we can able to maintain asset management, and then maintenance oriented, how it will be operation, all the things we can able to monitor in that what is an COMAS. So COMAS is mainly we have a data consistency is available, so unique object orientation as I said, and then common standard available in that, and then we have a end-to-end flow data through the entire life cycle. If you are changing that sensor data, it will be going to that another department which will be having that all the data. So if you are before that someone has told that if you are changing that motor from 2 HP to 5 HP, then that it will be directly intimated to some other engineers like electrical engineers. They will automatically give an intimation through that they have, it is a one common database. Once you change somewhere else, then the electrical engineer will know that how to, then he has to replace that starter. It will be capability of 5 HP, or it will be having that wire thickness, all the things has to be, then he has to be change all the things in that entire plants. So then all the intimations we can able to give it in this platform. So not only that electrical engineer, process engineer, they have a systems engineer, piping engineers also work in that platform, instrumentation engineers also work in that platform, automation engineer. So everyone can works in an one platform which will be called as an COMAS. It will have a unique database also. So through that each and every person will have some certain works, they can able to do it in that own itself. So once for license for academics it is not a perpetual license, it is a yearly license only available. So 10 users nearly 60,000 for academic is available. But only for COMAS, but in this there are some of add-on modules are there. So for if you are adding with VR, so for that one user it will be cost around 50,000 per year. So after that, if you want to implement in your AR is fully based upon that tablets and mobile for mainly for maintenance oriented works. So for that also they have separate license. So like that different licenses are there. For COMAS itself they have a 3 different license. For basics all the data available, and then VR separate license and AR separate license. So in distributed control system is majorly based upon that automation processes that only, which will not maintain that what type of PNID is available in that plant. What is PNID is mainly a piping and instrumentation diagram. So what is the length of the pipe, what is the size of the tank, all the things which will not have a certain data digitally will be available in that DCS. So it will be available in some other platforms. So no, this will for controlling. Distributed control system is only for controlling the hardware. Main thing is that it will control whatever that you are having the hardware, it will control all the hardwares. So it will do that controlling action. You want to apply the PID algorithm on that. So whatever that the things which can able to do it in that distributor DCS, distributed control system. Aspen is also there. Aspen is mainly for similar that Aspen we have a GPROM is also here from Siemens. Aspen is mainly for a chemical oriented analysis. So if you have any reactor is there, so in that reactor if you are putting any 2 types of chemical, what will be happening. So like that simulation only in that process only we can able to get it for in Aspen. Aspen? Operational aspects also not covered in aspects. But in a simulation of a single process we can able to do it in that chemical simulations. Majorly, it will not cover any data. It will cover only if that how that process it will done in that chemical oriented only we can able to done. But in COMAS we can able to enter data like asset oriented things also, in which place that valve is located, so in which floor in that how long spaces, in which place that map area also we can able to locate that valve is there, where it is located. All the things can be we can able to integrate it with the COMAS, and then where it is that MCB is located, like each and every things we can able to integrate it in one single software which is called COMAS. So entire plant we can able to digitalize and then we can keep it in your system itself. So that's what it will be more cost for industry's purpose also. For educational they are giving very less amounts. we are going to try to implement in NLC, Naval Lignite Corporation also. Before that, we have implemented in ONGC, and then we have a Cochin refinery. All the things also we are doing some works. All the things also we are in such some of the parts we are going for digitalization. All the data we are creating for that plans. Like that, we can able to create it and doing giving to that. So Kevin Care, so Avin, all the things also we are trying to get all the data and give the digitalization, all the things also.
You want some small hands so that they will be clear. They are getting it. Plant means very big. So
Yeah, plant, yeah, it will be very big.
they are not able to have perception. That's what when you are saying plant, it's very big plant. You are
Yeah, but that's what.
about the pipe, switchboard,
Yeah.
switchgear, everything you are telling about.
Complete simulation only I am telling for. Orange. Video on that. வேணாம் இதில் இருக்கு வீடியோ. சின்ன பிள்ளை எந்த வீடியோவே இல்லையே. எதுவுமே இல்லையே. இல்லை இல்லை ஒன்றுமே இல்லை. அவன் நாளைக்கு வேணா எடுத்துகிட்டு வரேன் வீடியோஸ் எடுத்துகிட்டு வரேன். எங்கே இருக்கு Tomorrow I can get a video of how it will works all the things. நிறைய இருக்கே, 50க்கு மேலே இருக்கு. இன்னும் போதுமா? சரி, ஓகே. 56 ஆகுது. எழுபத்தொன்று இருக்கு, இன்னும் 50 இருக்கு. சரி, ஒரு 4-5 போறேன். So in process industries, the major things we have to see in that feasibility studies and basics engineering is the first thing. So these are comes under that process engineer can do that entire process, and then detailed engineering. So from basics engineering, it will have a block flow diagram, process flow diagram, and all the things will comes under that basics engineering. So detailed engineering will have a PNID, so piping and instrumentation diagram of an entire plant. So procurement, how they are procurement, fabrication and constructions, and then for commissioning, while you are for commissioning, there will be automation and control will be there. So for commissioning, there will be how we can able to control all the plant. So for that, E&IC will comes into that major implementation. So what are the sensors we are going to use in that? How we are going to control that automation plant? Like we are going to use PLC, DCS. So what are the major control systems? All the things will be comes under that, and then startup will comes, and then operation maintenance, and then revamp. So this is the life cycle of an one process industries. So from the beginning stage to how to it will be closing. So these are the stages available in that process industries. So like that, one engineers will work on that certain levels, So do that necessary action, all the things also possible in that. So in fabrication, construction, civils and architecture, procurement, all the things can be done. So in basically there are comas will have a certain platforms. These are process, automation, operation and life cycle. These four are the major divisions will have in that comas. In that process itself, feed, PNIDs, pipe spec, isometric, 3D integrations all comes under that process oriented things all comes under the process engineers. And then we have automation will have that electrical instrumentation and controls and logical. So logical will depend upon that what types of logic you are going to implement to control that plant. So if you are going to use PLCs, all the things can be comes under that logical. And then third one is an operation scenarios. So how the plant will be operated, MRO, shutdowns, and then we have inspections. So maintenance oriented things, all the things can be comes under that operation scenarios. And then last one is an life cycle. So life cycle, entire life cycle, what are the things we have to see in that? So project quality management, what are the qualities of that product which are available, and then the second one is an walk inside, so which will be a VR thing. So last one is a mobile solution which will be an AR. So these three are available in life cycle orientations. So these four are main things for main platforms available in that comas. So in that feed, as before itself, we can able to create a block flow diagram of an entire plant, and then we can able to create a process flow diagrams, and then we can able to find out that errors are available in that process flow diagrams, and then we can able to create use that process flow diagram. We can able to convert that process flow diagram into PNIDs also. So once you create a process flow diagram, we can use that inbuilt algorithm to convert it into the piping and instrumentation diagrams also. And then in this PNID itself, we have a detailed plant is also there. So this part, one small plant, it will be we can able to get it as what Sir told. So one sump is there. From that, the water management will happen in that one area. That in that area there will be 2 tanks is there. So from that sump, the pump will pump the water to that 1 tanks, and there will be 2 level sensors also there. And then each valve will be a electrically operated valves. So once it will have a 70%, the valve will be 80%, the valve will be closing. So another valve will be opening, like that. Different scenarios we can able to create in that things also possible in this. So there are different elements available in your libraries itself. So through that we can able to drag and drop, and then we can able to create a piping and instrumentation diagram in your GOMAS platform itself. So here we can select each and every symbols as an objects. So while you are using in AutoCAD or some other, it will be a dumb data, like it will be does not having any data, all the things. It is just a symbols like that. But here we have object orientations, all the things, 3D models, and then what are the things available. All the things can be we can able to integrate it in that GOMAS platform itself. So benefits of using that PNIDs is having that international pipe standards. All of the data will be and then we can able to detect error yearly while changes are happens. If someone changes in that PNID, it will automatically we can able to find out all the things, and then we can able to integrate that workflow with any other objects also. So we can able to integrate that PNID with the simulation purpose, all the things also we can able to integrate in that. And then we have a pipe specs, isometrics, and then 3D integration. All comes under that what is that pipes American standard, and what is the pipe material available, glass fittings, all the things will comes under that pipe specs. Isometric view and 3D views comes under that each and every object which has an what is the different types of views available, and then what is how it will be connected with that. You are putting just a symbol from that libraries. So we have to integrate with that 3D models. So if you have any 3D models related to that your original CAD models available for your any motors, we can able to integrate with that. So through that we can able to communicate with that 3D model with your PNIDs pumps. So if you have a motor here, same motor we can able to integrate a 3D model tool, CAD models, we can able to integrate with that 3D integrations. we can able to integrate all the motors, data, all the things can be, we can able to integrate with this. And then automation, while coming to that automation, we have a COMAS E and IC. So E and IC, we have an electrical circuit diagrams, we can have an cabling diagrams, auto loops, templates, all the things are comes under that single line diagram also we can able to create. And then cabinet designs also we can able to create. So what are the components available in that in that panels, we can able to find out, and then we can able to create all the diagrams in an digitalization, and then we can able to view that cabinet designs also in that panel where it is mounted, that motor is where it is, that MC motor circuit protection switch is there, like that each and every designs 3D view of that cabinet, all the things will be comes under that E and IC. So which can be, we can able to find out all the data in a single platforms also. And last one is in that automation is an logical. So for logical function diagrams and the logical plans, loop diagrams, tag list also comes under that. So if you are having that one level sensor means, so for that level sensor how it is functioning. So functional block diagrams also we can able to store in that COMAS itself. So because you are using that any DCS or any control system, you can just implement this controller diagram in your PLC or DCS, then it will works on that. So there you need not to create any data from in an DCS or PLC to control all the things. All the data will be available in one platform. So through that we can able to transfer all the data. So if you want to take simulation, we can take a PNIDs for a simulation. If you want to do that testing for how that automation has been done, for that we can have all the function diagrams, all the data. Through that we can able to implement and then test all the things. And then we have a loop diagrams also. So here some of the things will be wirings. So if your sensor is connected to that IO tag number 1, so in that different types of IOs are there in that in industries they have PLCs which have multiples of IOs. They have 48 IOs. In that 48 IOs, that level sensor will going to that what level, what number of IOs. It will going to the 10th IO or 11th IO. Like that, that wiring will be details all comes under that loop diagrams. So like that there are multiples of sensors, n number of sensors. So n number of sensors will going to that what IOs available in that platforms in that controller, what number it is located. So like that all the things can be, we can able to couple and then we can able to view in this platforms itself, and then we can able to get that bill of materials we can able to generate from there itself. And then once you generated, you can get all the items available in that plans for ready to use. And then this is a same object view in different places. So is example, I have one motor is there, so it will be having in that center left side will have a PNIDs. In that PNID itself, in the right side we have a electrical diagram. So same motor will be having the data sheets also. So all the three items we can able to view in this only in one platforms, and then we can able to do the programming, all the things also we can able to store in this platform itself. So the COMAS, what is COMAS, we can able to see. This is we can able to go to the electrical diagrams, data sheets, everything we can able to view in that single platform. So the same object will be we are going to use in this. So each and every object we can able to navigate from one another. So if you change it here, all the things can be, we can able to view in all the places also, we can able to find out all the things. So this is a loop diagram. So that level sensor where it will be connected, all the things also we can able to view in that. So where it is that navigated to 3D also possible in that. 3D models also we can able to navigate. So once you integrated all the things, we can able to navigate all to that 2D to 3D, all the things is possible in that. And then the third one is an operation oriented things. Tomorrow. So then we can see tomorrow about that operation oriented things, and then AR, VR, and then we can have some hands-on on this.
Okay. Yeah. So thanks to Sudarshan sir. So actually, this is the actually, if my guess is correct, means if I am working on solar thermal plant, but tomorrow if I am not interested, I want to work on say some other pharmaceutical industry or something like that. At the time, I could not go for entire modeling. It's very difficult for me because again it will take years. At that time, I think this may be the best option for me because I can get the data. From the data, I can predict which is the best option, how to design. In such a case, it could be a best option because it consists of modeling, control, all the electrical block diagram, all the datas. That is a way. I hope this is a software could be a best software. But still, tomorrow we'll just see how. We'll make small plant how it is going to work. We'll just see. Okay. Yeah. So now today is the end of the session. Right now you can go and join for the tea break. It is there in the hostel up to Sandeep. Up to what time? Okay. Till 7 they will provide you the tea break. Tea and snacks will be provided. Then we'll tomorrow at 10 o'clock we'll sharply will join for. Thanks to one and all. Thanks.
यार ये कैसा है भी, मेरे समझ में कुछ नहीं आ रहा यार। अभी कैसा करना है यार, ये कैसा कैसा करना है